ऑलरेडी 12:30 प्लस हो चुका है। सो बेसिकली आज के टॉपिक में जो इन टुडे टॉपिक वी विल बी डिस्कसिंग अबाउट द डायनेमिक प्रॉपर्टी एंड particularly about the ground vibration. Okay, so that is in our also, and that is in our GATE syllabus also. So just wait, please. So already we have covered this ground vibration. What are the factors which affect the ground vibration and how to find out the peak particle velocity? That all we have discussed in the blasting, means in the development topic. Again we are covering here because of the again the ground vibration in our syllabus, that's why. So basically the ground vibration is mainly due to the dynamic property, means dynamic loading and the stress in the rock and rock mass. So what are the dynamic properties? So dynamic load produce energy and releases at the source of impact and thereafter passes into the surrounding environment. Dynamic load means mainly due to the either due to the blasting, the cause of the dynamic load may be the blasting, or due to the stress distribution around the surface, or due to the earth surface movement. So dynamic load produces energy and releases at the source of impact and thereafter passes into the surrounding environment in the form of pulse and vibration, which is called as seismic or elastic wave. So basically this dynamic load creates a vibration in the surrounding rock mass, surrounding environment, and that vibration propagates in the form of pulse and vibration, which is called as the seismic or elastic waves. And seismic wave of different mode of origin have fundamental similarity but differ in their amplitude, wavelength, and frequency. So they basically we will discuss about the seismic waves, PA wave, S wave, relay wave, love waves. So what is the surface wave, what is the body wave, and that is also important from the exam point of view. Means if there are the maybe it is asked which one is the surface wave, which one is the body wave. And so you maybe you have to select the correct option. Depends on means P wave, S wave, relay wave, love wave. So that we will discuss what are the different waves. Okay. So basically amplitude is the magnitude on the y-axis, means that. So that is the amplitude, and frequency means number of occurrence in a time period. So that is the frequency. So this is the just a curve, what is the frequency and spectrum. So application of dynamic property of rock and rock mass. So where this dynamic property of rock, like the dynamic modulus of elasticity, dynamic Poisson's ratio, these all where it is being applied. So basically rock mass characterization by determining dynamic rock strength, then dynamic elastic constants, then propagation characteristic of seismic wave, repeatability of the rock, and blastability of the rock. Then a study of phenomenon and of monitoring of earthquake, rock burst, coal bump, gas outburst, so this and blast induced vibration, which is the ground vibration, fly rock, and noise. So basically these dynamic property are used for a study of the phenomena and monitoring of earthquake, and then dynamic based on the dynamic properties of the rock, the rock mass characterization based on the dynamic rock strength, then elastic constant, then propagation characteristic of the seismic wave, means whether it is the body wave or the surface wave, and the repeatability or blastability of the rock. Then design of blasting in the rock. This dynamic property also affect the design of the blasting in the rock. Geophysical investigation like location of fault, fracture zone, exploration, seismic stress measurement, then delineate void or unconformity. So these dynamic property are also used for the this geophysical investigation and rock structure stability analysis, and design of a structure prone to dynamic load, and design of a structure prone to dynamic load, and design and selection of excavation and drilling equipment. So these are the basically the application of the dynamic property of rock and rock mass where it is used. So what are the sources of the dynamic load? This is just means not important from the means what are the application of the dynamic properties. So just go through once that for understanding purpose. From exam point of view, whenever I encounter the important that I will inform you that from this topic most important is that that seismic waves, types of the seismic waves, and the ground vibration, and the peak that peak particle velocity (ppv). That is the only important. So just go through once, means so the application of the dynamic property of rock and rock mass. Then sources of the dynamic load is the natural cause like earthquake, rock burst, or coal bump. Coal bump is what? Sudden failure of the coal pillar, which release a large amount of the gases and the large amount of the gases and the energy which is stored in the coal pillar at a high pressure. So basically this coal bump is also sometime a disastrous, means it may have the shattering effect on the surrounding area. So natural sources of the dynamic loads are the coal bump, rock burst, earthquake, gas outburst. And man-made sources are like blasting, pile driving, rock cutting or excavation, traffic vibration or machine vibration. So basically means whatever the factors by which you can induce or changes, means induce or changes the load or stress condition, that is the basically the source of dynamic load. So seismic wave propagation in rock. From here, this is important topic, means important part started. So number of seismic wave are generated at the impact point or source of dynamic load. So basically at the impact point or source of dynamic load, number of seismic waves are generated, and it progresses spherically outward with the diminishing amplitude. And each wave behaves in a characteristic wave, and characteristics slightly depend on elastic property of rock. So basically there are two main types of the waves, that is the body wave and the surface wave. And body waves can travel through the rock strata, but surface wave can only move along the surface of the rock strata or ripple on water. Like a ripple on water, the surface wave moves only along the surface of the rock, whereas the body wave propagates through the rock strata. So basically these body waves are responsible for the vibration, means ground vibration, and these surface waves are mainly responsible for the noise or air blast. Okay. So this is the dynamic load contact, means point or source point, point of impact. And from here, the seismic waves are generated in the spherical form with the varying amplitude, means with the distance amplitudes get diminishes. So this is the body wave, and which propagate on the surface like a ripple on the water body, that is the surface wave. So two major group of seismic wave, body and surface wave. Body wave propagate through the body, whereas surface wave propagate or travel along the surface of the medium. Okay. So basically body wave is the P wave and the S wave, that is the body wave, and afterward that is the surface wave. So what are the body wave, surface wave, that we will discuss. So type of the body wave is the P wave. So the first kind of body wave is the P wave or primary wave. So this is the fastest kind of seismic wave, and the P wave can move through the solid rock and fluid like water or liquid layer of the earth. So basically it pushes and pull the rock, it moves through, just like sound wave push and pull the air. So while it means propagation through the rock is, it pushes and pull the rock like sound wave pushes and pull the air. So P wave is also known as longitudinal or compressional and dilational wave. So just remember, P wave is also known as the longitudinal or compressional, means like a sound wave, it is compressing and again being reflected. So compressional or dilational wave because of the pushing and pulling it does. So P wave makes particle to move in the direction of wave propagation. Okay. So body wave frequency is from 15 Hz to 100 Hz. Okay. So this was about the P wave. And P wave in the rock sample depends on elastic property, then Poisson's ratio and the modulus of elasticity and density. And by using this relationship, you can find out the P wave velocity. Okay. So primary, that P wave velocity is square root of the 1 minus Poisson's ratio multiplied by the Young's modulus divided by 1 plus Poisson's ratio multiplied by 1 minus 2 times of the Poisson's ratio, all multiplied by density of the rock. So just remember this equation, means how to find out the P wave velocity in the rock sample. and primary wave velocity is 1 to 8 km per second near Earth surface, and interior of Earth is 13 km per second. So as we know, the basically these P wave is the, or primary wave is the compressional wave, and it moves through the pushing and pulling, means compression throughout through the rock surface, rock mass. So due to that, the in interior of the Earth, its velocity is higher compared to the surface. Okay. So this is the basically the propagation of the direction of propagation, and in the direction of propagation of P wave, also the particles moves. Okay, like the compression, you can see here it is compressing, and again here it is means pull it, here it pulls, then again pulls, then again here it pulls and pushes. So basically just like a propagation of the sound wave in the air, it pushes and then pulls the particles. So like due to the compression. So next is the type of body wave. Next type of the body wave is the S wave. Second type of the body wave is the S wave or secondary wave. So P wave is the primary wave, and second type of body wave is the secondary wave or S wave. And S wave is slower than a P wave and can only move through the solid rock, not through any liquid medium. So basically, S wave only move through the solid rock, not through the liquid medium, unlike P wave, which move through the both solid as well as the liquid medium. And S wave is also known as the shear or distortional wave. So just remember the alternative name also, which one is the longitudinal wave, which one is the shear wave and distortional wave. And S wave moves rock particle ups and down. Basically, P waves moves the particle along the direction of propagation. Here S wave moves the particle ups and down, means horizontally polarized S wave, or side to side perpendicularly polarized S wave to the direction that wave is traveling. Means in the to the direction of propagation of wave, the particles moves perpendicular ups and down like this. Okay. So the secondary wave or S wave velocity can be found out again by using the Poisson's ratio, modulus of elasticity and density of the rock, and it is approximately secondary wave, as we know that S wave or secondary wave velocity is less than the P wave or primary wave velocity, and it is about 60% or 0.6 times of the primary wave velocity. So just you remember also this relationship. So here you just say distortional or shear wave propagation, means it's caused the particles to move ups and down perpendicular to the direction of propagation. Okay. So this is the basically effect of P wave propagation is that it causes the compression and dilation, and the effect of S wave propagation is that shearing basically. Okay. So basically due to P wave propagation, it caused the horizontal displacement or horizontal deformation in the surface structure, whereas the S wave caused the either the means caused the shearing effect, means either the vertical as well as the transverse. This, if there is a shearing is in horizontal direction, so it caused the transverse distortion in the structures. That's why it is called a distortional wave also. Next is the type of surface wave. So surface wave travel only through the upper surface, that is the surface wave are of a lower frequency than body wave. So they arrive after, just give me a minute. So next is the surface wave, and its surface wave travel only through the upper surface, means along the like the ripple in the water body, ripple on the water surface, it travels only through the upper surface, and surface wave are of a lower frequency than body wave. So they arrive after body waves. It is the surface wave that are mostly responsible for the damage and destruction associated with the ground vibration. And surface wave frequency less than 15 hertz. That body wave frequency is in between 15 to 100 hertz, that body wave frequency. But here a surface wave frequency is less than 15 Hertz. Some of the commonly known surface wave are the Rayleigh wave, Love wave, Stoneley wave, and guided wave. So these are the basically the surface wave. So you remember also the name of the what are the surface wave, which waves falls under a category of surface wave and the body wave. Okay. So till now, whatever we have discussed, is it clear, Sibu and Rehal?
Yes, sir.
Yes, sir.
Okay. So next surface wave, the first one of the surface wave is the Rayleigh wave and R wave, which is named after the John William Stewart and Lord Rayleigh, occurs near the interfaces and free surface of rock, just like a waves roll across a rock, lake, or an ocean. So basically it occurs near the interface and the free surface of the rock, just like a waves rolls across a lake or an ocean. So basically it's occur near the free surfaces, means near the free surface of the rock, and it cause elliptical particle motion in a vertical plane in the same direction that wave is moving. So basically this Rayleigh wave causes the particle to move in the vertical plane in the elliptical motion in the same direction that wave is moving. So basically just a wave. So basically this is the direction of propagation of the Rayleigh wave, and it causes the particle to move in the vertical plane to the direction of propagation in the elliptical motion particle. So this basically this surface waves cause the particle to move in the vertical in the elliptical direction motion particle. Okay. So Rayleigh wave velocity is approximately 0.919 times of the S wave, means secondary wave velocity. So this in the if we make a means if we compare the different seismic waves on the basis of speed, so P wave velocity is the highest, then secondary is the which is the 60 times or 0.6 times of the S wave, and then the surface wave comes. So surface wave basically Rayleigh wave velocity is 0.91 times of the secondary wave velocity, and maximum velocity is the 4 km/s. Okay. Oh, next is the Love wave. So Love wave, L wave, named after A.E.H. Love, a British mathematician who worked out the mathematical model for this kind of wave in 1911, and it is the fastest surface wave. So basically it is the fastest surface wave. So it is the fastest surface wave. It occurs in the lower velocity surface layer overlaying the higher velocity layer and moves the ground from side to side. Basically here it moves the ground from side to side, and it occurs in the lower velocity surface layer, which is overlaying the higher velocity surface layer, and it is confined to the surface of crust, and the Love wave produce entirely horizontal motion. So basically that Rayleigh wave produce the basically the vertical motion in the elliptical, means in vertical plane elliptical motion. Here Love wave basically produces the entirely the horizontal motion, and it is the fastest surface wave. So Love wave velocity is approximately around 4.5 km/s. Okay. So next is the Stoneley wave and the guided wave, means third and fourth type of the surface wave. So Stoneley wave occurs between two layers similar to shear wave, and Stoneley wave velocity is approximately 0.09998 times of the P wave velocity, means just about 0.1 times of the P wave velocity. And guided wave is confined to the particular layer, like water layer, coal seam. It is confined to a particular layer, and this Stoneley wave basically occurs between two layers, and velocity depends on the wavelength, layer thickness, density, and elastic constants. So this is the guided wave. So out of all these six or out of all these 6 waves, seismic waves, which falls under the category of body wave and surface wave, the first 4 are the more important, that P wave, S wave, and the relevant love wave. So basically the ground vibration, the propagation of seismic wave or elastic wave creates oscillation or vibration of ground. So basically it creates the oscillation. So there will be the displacement, particle velocity or acceleration as it is experienced by each particle. So termed as the particle motion, and which is measured by particle displacement will be velocity divided by this 2 pi frequency. So basically it is the like that omega means in the rotational motion dynamics, that circumferential velocity is what 2 times means omega angular velocity multiplied by the radius. So here same that particular velocity particle displacement is equal to the velocity divided by angular velocity, like 2 times 2 pi frequency, and particle velocity will be what? Angular velocity multiplied by the diameter, and particular acceleration will be what? Omega square r. So it is like a similar to the rotational dynamics of the particle. So particle motion or vibration has detrimental effect on the structure which are subjected to such vibration, and particle velocity is the best index for assessing the degree of damage to a structure due to ground vibration. So particle velocity basically means in the case in mining context, basically we find out the peak particle velocity, which is the best index for assessing the degree of damage. Means based on the peak particle velocity, we try to assess the degree of damage to the structure due to ground vibration. So strain due to elastic wave will be velocity divided by this particle velocity divided by the wave propagation velocity. That is the strain due to elastic wave. And stress due to elastic wave will be what? That means modulus of elasticity is a ratio of the basically stress to strain. So stress due to elastic wave will be modulus of elasticity multiplied by the strain due to elastic wave. So we will get this equation. Okay. So mine rock blast induced vibration means out of that all 6 seismic waves. Next important one is this mine rock blast induced vibration. On what factors it depends, how to find out the peak particle velocity, and what are the geological parameters that affect the ground vibration. So vibration intensity depends on distance from point of blasting. So that is the means distance from the point of impact or point of dynamic loading. Then quantity of explosive per delay. That's why here comes the basically maximum MIC, maximum instantaneous charge. Means at a time, at a particular delay, suppose 25 millisecond delay, at 25 millisecond delay, how much explosive are getting detonated. So that is the basically quantity of explosive per delay. That is MIC, maximum instantaneous charge. So on that also vibration intensity depends. Then nature of rock medium of wave propagation. So the nature of rock medium also affect the vibration. If whether it is the too much jointed or fractured, or whether it is the consolidated rock. Then blast pattern and design is also whether you are going for the V pattern or diagonal pattern or point of initiation. Okay. Oh, these are the factors on which the vibration intensity depends. And peak particle velocity is basically the peak particle velocity is the K, which is the side constant and that is the basic. This is the scaled distance. This is the basically the scaled distance, that is the radial distance from the point of the blast divided by a square root of the explosive charge per delay. Means maximum instantaneous charge per delay. This ratio means the ratio of radial distance from the point of blast or point of impact to the a square root of the explosive charge is known as the scale distance, and this scale distance means a power, and that a square root of this beta, which is the site constant. Means in the question it will be given that the site constants are the k and b beta in this much value, and have to find out at 100 meter of distance and explosive are getting initiated. So find out the peak particle velocity. So just use this relationship to find out the peak particle velocity, and even means the prescribed standard of peak particle velocity by the DGMS, means depending on the distance and the frequency of the seismic wave, as well as the structure, means nature of a structure, whether it is the pakka or hut, like a hut or mud hut. So basically these peak particle velocity, suppose you are calculating you are getting the peak particle velocity, and we compare with that peak particle velocity, and if it is under the prescribed or prescribed standard, then means the blasting is means haven't caused any damage to the structure. If it is over than the prescribed or prescribed standard, then there is a chance that blasting has caused the blasting induced that damage have occurred in the structure. So this is the relationship, just remember, to find out the peak particle velocity, and I have already covered this in also while covering the blasting. So this is the peak particle velocity, and the log of, if you plot a log of ppv, this is the ppv, and the this log of the scale distance, this is called the scale distance. So we will basically get a, basically if you plot a log of ppv equal to log k multiplied by d, so basically it will be log k plus this is the log d by root under w and multiplied minus beta. So basically the c constant will be, if you plot a curve, so basically slope will be minus beta, and constant y equal to mx plus c, and constant that intercept, y intercept will be log k. So this is the y intercept is the log k, and slope is minus beta. So slope of the curve is the beta, and it is the minus, that's why it is linearly decreasing order. Okay, so this is the graph plotted between the ppv and the scale distance. Okay, so basically means I assume that this can be easily plotted by you. This is just have to use the basic relationship of the logarithmic log. So damage criteria due to ground vibration. So the damage criteria was proposed by many organizations, including USBM, DGMS, Indian Standard, etc., based on the permissible peak particle velocity in millimeter per second. So peak particle velocity is measured also, it is measured in millimeter per second, and frequency of the ground vibration for various type of structure. So basically here we consider the frequency of the ground vibration and the peak particle velocity in the millimeter per second, and compare with the permissible, that prescribed standard. So basically that geophone and along with the that seismograph along with the geophone are used to monitor the ground vibration. That records, or basically in that seismograph has the transducer that record the peak particle velocity as well as the frequency. And if you have to also do the measurement of the air blast or noise, so we use the microphone or the geophone along with the seismograph for monitoring of the noise or air blast. So the criteria based on the permissible peak particle velocity in millimeter per second and frequency of the round vibration for various types of structure as per DGMS are presented. So basically these are the basic criteria which has been prescribed by DGMS. The damage criteria wise building structure belonging to owner. So if the building is or a structure belongs to owner, in that case the domestic house, if frequency is lesser than 8 hertz, so permissible peak particle velocity is 5 millimeter per second. But if frequency is 8 to 25 hertz, so permissible peak particle velocity is 10 millimeter per second. and if it is 25. So basically, based on the frequency and the type of a structure, peak particle velocity has been prescribed by the statutory body. So can anyone answer why? Means if the frequency is less, even at that peak particle velocity is less, but with the frequency, as the frequency increases, the peak particle velocity, permissible peak particle velocity increases. So what is the reason? Anyone have the idea? What is the reason behind the, with the increase of the frequency, peak particle velocity, that permissible means maximum allowable peak particle velocity also increases with the increase in the frequency? Vignesh, Rehal, and Sivu, if anyone have the idea.
Sir, can I ask once again, sir? Not understood the question, sir.
Actually, in this chart, you see if the frequency of the ground vibration, if the frequency of the seismic waves are less than 8 Hertz, at that time permissible peak particle velocity is 5 millimeter per second. What if the frequency is 8 to 25 Hertz, then permissible peak particle velocity is 10 millimeter per second. If frequency is greater than 25 Hertz, then permissible peak particle velocity is 15 millimeter per second. So basically means with the increase in frequency, the peak means maximum allowed peak particle velocity also increases. So what is the reason behind this? Means frequency is increasing, then peak particle velocity means up to that you can produce the peak particle velocity is also increases. So reason behind this means, if anyone means if anyone have not studied, then he can understand that by if the frequency increase, then the peak particle velocity should decrease. But here it is what, that if the frequency increases, the peak particle, maximum peak particle velocity also increases. So what is the reason?
Sir, I'm just guessing, sir. Building structure now, sir, they have some frequency. If the peak particle velocity is match the frequency, means the building will collapse, sir.
Okay, yes. You are little bit right. Means you are in the right direction. Actually,
resonance frequency, sir. You resonance, sir?
Yeah, resonance frequency. That is basically the impedance matching. I talk now. So that is basically the density and the velocity of detonation. If in the case of the means when the impedance matches, at that time maximum transfer of energy from one body to another body takes place. So basically the structure domestic means structures have the lower resonance frequency, and if that times if the velocity is high, means there will the maximum energy will transfer from the ground to the structure. That's why at the lower frequency this velocity has been kept minimum to allow the minimum transfer of the energy from ground to the structure, which may cause the damage or destruction to the structures. Okay, so basically due to the resonance frequency and the impedance matching, and impedance is what? It is the product of the density multiplied by the velocity of seismic wave in the ground or velocity of detonation in the case of the explosive. So here the same, even in this impedance matching criteria is used while selection of the explosive also. Means you have the density of the rock, you have the peak particles, you have the P wave and S wave propagation velocity in the rock, means by knowing the Young's modulus and Poisson's ratio and density. So you have the impedance of the rock. Now you have to select the density and the velocity of that detonator, which may cause the maximum transfer of energy from the explosive to detonator. Sorry, from explosive to surrounding rock mass. And same concept apply also to the from rock mass to the structure. So if the impedance matches, at that time maximum energy will transfer and that will cause the damage. That's why at the lower frequency, means that resonance frequency, the peak particle velocity is kept minimum. Okay, so is it clear to everyone?